Yes. All right. So here we are with question number 3. So there's several ways we can do this, but we need to work quickly. So I'm going to show you the quickest way to work it. Then I'm going to show you the correct, quote unquote, way as far as showing your algebra, or if you have a problem that's a little bit more difficult than this problem and you have to use ratios. So first way, when I'm looking at this, I would say half an inch equals 18 miles. And I need 2.5 inches is what I'm looking for. So by process, I could just say half an inch equals 18. Therefore, 1/2 and 1/2 is 1. So 1 inch, double this, is 36. I need 2.5, so I'm going to double this again, which will give me 72. I still, and just looking at my answers, I could actually stop. And because I'm already at 72, which means all these are gone, so my answer is 90. But if you just wanted to double check, you still need another half inch. So you would add 18, and so 2.5 or 2.5 would indeed give you 90. But let's say the problem's not as easy as that, so you actually need to know how to work it the other way with the ratio method. So the other way to do this problem is, again, you would say 1/2 inch equals 18 miles. And then you have the 2.5 inches. Well, anytime you're going to use fractions, you need it to be in an improper. You could use 2.5, but again, we're trying to do this without a calculator also. We're assuming we don't have a calculator at this point. So I'm going to do it both ways. So I need to change 2.5 to an improper, which means if you're remembering way back when you learned this, you went 2 times 2, which is 4. You added the top number, which would give you 5 over 2. So again, that was 2 times 2, multiply these two together, add the top, that gives you 5/2. That's what you want to use, is the 5/2. And you want to know how many miles is it that equals 5/2. Notice I'm going to set it up as a ratio. That's inches over inches equals, I have 18 miles. I want to know how many miles is 5.5. So these two should be across from each other, and the half and the 18 should be a half and the other. To make this look proper, I'm going to erase the equal sign here, because now I have two ratios that are indeed equal to each other. So I'm going to put it here. And now I'm going to cross multiply. So I'm going to say 1/2 times x, which is 1/2 x, equals, multiply the other way, 5/2 times 18. And I'm going to put 18 over 1. Well, again, you could grab your calculator and go 5/2 times 18. Or, if you remember your fractions, you could say 2 will go into 2 one time. 2 would go into 18 9 times. So now you have 1/2 x equals 5 times 9, which is 45. 1 times 1, which is 1. So that's 45 over 1. But again, you're trying to solve for x. So that means I need to either divide both sides by 1/2, which I may need to use the calculator for that, or I can say I can multiply this side by the reciprocal, 2 over 1, and that will knock that out, which is awesome. But whatever you do on one side, you have to do on the other. So I need to multiply this side by 2 over 1 also. And that will give you x equals 45 times 2, which is 90. So therefore, we get the same answer, obviously, by just thinking it through as far as what does the inches equal. Moving on to number 4. It's really only one way that you can do this problem as far as setting it up. So you're given basically a formula, and all you have to do is plug in the numbers into the formula. Therefore, 450 goes in for F. I do not know what C is, so I'm writing that down. D, however, they tell me is 10, so I'm subbing 10 in for D, and I'm raising it to the third power. If you do have a calculator, you would put 10 raised to the third power into the calculator, or you could just say, well, that's 10 times 10 times 10, which means 1 times 1 times 1 is 1. And then I have 3 zeros. So 10 to the third power is 1,000. So that means 1,000 times C equals 400. I was trying to solve for C, so I'm going to divide opposite operation by 1,000 in order to get C all by its little lonesome. So notice the 1,000 cancels out. You can grab your calculator again and put that in, or you could just knock out the zeros. And if you know that 45 over 100 is the same thing as moving your decimal 2 places on the 45 to the left, you'll get 0.45. So either way, with the calculator, or just that knowledge that 45 over 100 does equal 0.45, which is very similar to a percent idea, which is what is happening on number 6. So as we read number 6, we find that Jorge is making $12 an hour. And he did so well that he is going to get a raise. His raise is going to, or an increase, right, means raise, is an increase of 6% of his current wage. That's very important right there. We can write that as a math term. As I said earlier, 6% is very similar, or is the same actually, as 6 over 100, because percent means 100, which also means the same thing as 0.06. You can move your decimal twice. So anytime you have a percent, you want to change it to a decimal. So it's going to be 0.06 of means times. So I'm going to go 0.06 of his hourly wage, which is 12. So 12 times 6 is 72. You have 2 decimal places here on the left, so it means you need to have 2 decimal places here on the right. So his raise is going to be 72 cents. So how much is he going to be making? He's going to be making $12 plus his 72 cents, which will give you the $12.72. As we move on to 4 more other pre-algebra problems, actually 3 more pre-algebra problems, so we need to discuss real quick. It says you're supposed to put the fractions 1/2, 5/6, 5/8 in ascending order. That's very important to pay attention to. You hate to do some work and then find out you put it in the wrong order. Therefore, you got it wrong. Ascending means you're starting small and going larger. And you're glancing at your answers. And you could do this one of 2 ways. You could put 1/2, 5/6, and 5/8 into your calculator and get the decimals and take a look at it. Or, let's say, again, you don't have the calculator. You could find a common denominator, which we probably need to refresh our memories how to get a common denominator for some of us, because this may have been a while. So we have the denominators 2, 6, and 8. We want all 3 of them to have the same denominator. So therefore, you're going to take the 2 over here, make factor trees, 2 times 1. You're going to take the 6, which is 2 times 3, and then the 8, which is 2 times 4, and you can break down the 4 a little further. Now to finalize this, you take everything that is new. In other words, starting here, you have the 2. Go to the next one. You already have a 2 down here, so you don't want to use that. You want to use the 3. Then you're coming over here. Again, you already have a 2 there, so you don't want to use that 2. But you want to use these because those are new. And if you multiply all those together, you do get 24. So that is my new common denominator that I'm going to use. I changed all the denominators on all 3 fractions. So therefore, I'm going to change all the numerators. Here, I'm going to go 2 times 12 to get 24. Therefore, it's going to be 1 times 12, which would be 12. 6 times 4 will give you 24. Therefore, 5 times 4, which is 20. 8 times 3, which is 24. Therefore, 5 times 3, which is 15. So if you're taking a look at that, you're supposed to, again, ascending, the smallest one would be 12 over 24, which is representing the 1/2. So that is the smallest one, is the 1/2. And if you look over your answers, F is the one that starts with 1/2. So F is the correct answer, but you could double check with the 5/8 would be next. 15 over 24, yes, that checks out. So that is your correct answer. 19, you're supposed to put it in scientific notation. You have these big, long numbers here, huge numbers. Be nice to make that money. First thing I'm going to do is actually add those two together. I'm going to come over here just because I need some more space so you can see it. You can, again, you can put this in the calculator. Some of you could probably do this in your head. Some of you may need to write it down. You should know you. What do you need? That's 7. 6 and 7 is 13. Notice I get 137, which is all that. That is correct. I can knock out E. There's no way E is the right answer because I remember that to be in true scientific notation, I need to have one decimal point in front. One number in front of the decimal point. So all A, and you can do process of elimination also. This one's different, so there's no way that is the right answer. Now you got to decide which exponent. And you go back to your one that you just added. Here's my decimal. You're going to move it. And you're going to count how many times you move it. That's 4. That's 5. That's 6. That's 7. That's 8. That's 9. There it is. So it looks like the rest. I moved it 9 times. So now my choices are A or D. These are now gone. If you remember, you want your number to get larger. So 10 to the 9th will indeed make it larger. 10 to the negative 9 makes your number smaller. Therefore, D has to be the correct answer. Last but not least, you need to find the fraction that is between 2/3 and 3/4. Again, you could get a common denominator, but I don't see that as being the quickest way to do this one, especially if you have a calculator. I would grab my calculator, and hopefully this knowledge you already know that you don't need to grab the calculator, but just in case, I'm going to put 2 divided by 3 and 3 divided by 4 into my calculator. So I am going to my home screen here in just a second. Second quit. There we go, home screen. So 2 divided by 3, which will give me 0.6667. And then 3 divided by 4, which you hopefully already know, is 0.75. So I need to find a fraction that's in between 2/3 and 3/4. Two-thirds, which is 0.67, and 3/4, which is 0.75, somewhere in between there. Looking at these, I'm going to do the same thing. I'm going to put 3 divided by 5 into the calculator. Now, if you didn't have a calculator, you would have to get a common denominator. And so you'd go back to the way that we did it, and it would take you a while. Or hopefully, if you know the size of this, that you know that one is 0.6, it's too small. This one is 0.833. That's way too large. Again, if you're not knowing, understand what I'm doing, I'm just putting it in the calculator. Next one was 7 divided by 12, which will give me 0.58. And then you would do the other ones just the same way. And you would find out this one, it doesn't work. Neither does this one. So process of elimination is 17 over 24. But again, we can go back and check it. 17 divided by 24 is 0.71 if you round it. 0.71 is in between. So that is correct. I said a common denominator is one way to do it. Another way you could do it is actually, which also has to do with common denominators, but you could add these two together, which means you have to get a common denominator, find out what it is, and then you would have to divide by 2 to find halfway in between. So that could be also another way of doing that without a calculator. But since you get to use one, why not use it to the best of your ability? And that is all that we have for today on pre-algebra. I'll get back to you guys when we start discussing the algebra problems.